Good afternoon, Doctor. I am by the names of Bincha Joshua Aaron. And for this task, you tasked us to use TJ3JS for our data visualization assignment. And for this, I chose to explore exoplanets using some NASA dataset. And the objective of this analysis was to perform and transform NASA's exoplanet catalog into interactive visualizations to enable discovery of planetary system patterns and characteristics, and also ease the understanding of how these planets' characteristics resemble the known planets in our solar system. So without further ado, I wanted to show. So this is the data set, and these are some of the columns in the data set. The data set has over 35,287 rows of data together with 14 columns. Some of those columns include the name, distance, planet type, discovery year, mass multiplier, radius, orbital period, and detection method. And the data ranges between 2017 to 2023. So these are some of the techniques I used. One was the bubble. Some of the visualizations I used for this was a bubble chart and the radar chart. The radar chart was basically to show the matrix, the different properties of a particular selected planet in terms of radial axis, mass, stellar magnitude, orbital radius, and period, and eccentricity, as we shall see later on in the in uh, in the what in the presentation. So for now, let me first go straight to the work. So this is my visualization. As you can see, it's exploring NASA planets using D3, and the main visual is a bubble chart that has some of these properties. Now I made it interactive in a way that I used SVGs to make sure I select a particular few planets that were discovered, depending on not less more than 200, but just to maintain the visualization simple. So you can clearly see here by default, if I select 2017, you can see these are some of the planets that were selected that were discovered in 2017. And this icon means these are gas giant like planets, as some others resemble, their properties kind of resemble those of our planet Earth. Those with this icon resemble the terrestrial planet like planets, and then also Neptune like. So most of these planets that were discovered within this time period have characteristics that resemble these known planets, as I earlier mentioned. So if you select, let's say 2019, you can clearly see these are the ones. So if we select this was, you can see when you hover around it, it's planet K2. Planet type, it's super Earth. That means it has characteristics that like that of planet Earth. Its distance from Earth is 259 million light years, and it was discovered in 2019, and its discovery method was transit. So these are some of its properties: the stellar magnitude, mass multiplier, radius multiplier, orbital radius, orbital period, and eccentricity. So here, this graph just gives you a more detailed view of the characteristics of this planet. So this discovery timeline graph basically shows how planets have been discovered over the years, and you can clearly see a lot were discovered in the period ranging between 20s. You can say 2016 to 2017, a lot were discovered during that period. And here you can clearly see most of the planets that have been discovered, the majority are Neptune-like, followed by, we can say, gas giant-like, and then super Earth, and then terrestrial comes last. Some of the highlights from this, we can conclude in summary that this project demonstrates how the DJ3 can turn abstract numbers into intuitive discoveries by linking this visualization. We can compare individual planets, track astronomical progress, educate others about planet diversity. And then, yeah, basically, those are some of the details and key takeaways that I learned while doing this assignment. Thank you, Doctor.